MongoDB for VS Code lets you build apps in a way that fits your native workflow and development tools. You can connect to MongoDB Atlas clusters or local instances, browse databases and collections, edit documents, and get a quick overview of schemas and indexes. It also makes prototyping queries and aggregations a breeze with dynamic playgrounds, syntax highlighting, and intelligent autocomplete. Check out MongoDB Atlas for free today. The first 10 listeners to enter the code MKT-Hansel at checkout will receive $100 in Atlas credits. Create your free cluster now and don't miss this opportunity for an in-depth exploration of MongoDB Atlas. Again, the first 10 listeners to enter the code MKT-Hansel, Hansel, at checkout get $100 in free credits. Hi, this is Scott Hanselman. This is another episode of Hansel Minutes, and today I'm talking with Kevin Hoffman. He is the CTO of Cosmonic and the founder of WasmCloud. How are you, sir?
I'm doing pretty good.
Thanks for hanging out. I am learning all about WasmCloud, and you can check it out at wasmcloud.dev. But I'm looking at some of my research, and I noted a few things. I want to go back some years. I wrote back in 2011 on my blog that JavaScript was becoming the assembly language for the web. You know, when did WebAssembly happen? We were already thinking about JavaScript as being like the lingua franca, the assembly language of the web. We were turning things into asm.js, but WebAssembly is a different beast.
Yeah, so WebAssembly sort of evolved after asm.js, and it's been around as a standard for a couple of years. But the community is still early, and the tooling and ecosystem around it is still very much early days.
So, but WebAssembly, though, it's built in. It's like back in the day, things would come out like SVG and different browser things, and we would always have to wait years and years and years. But basically, every browser has WebAssembly built in, right?
Yeah, by and large, pretty much every modern browser has WebAssembly support, and I'm pretty sure all the major ones also have it on their mobile browsers. So, if you're building or deploying WebAssembly workloads, I mean, that's really the promise for me, is being able to put it everywhere and more than just the browser.
Now, it turns out, as we were talking before, we'll say in the green room of this podcast, that you and I had worked together over 20 years ago on a website called ahunter.com. And I remember we had tables, nested tables, and one pixel transparent GIFs. There wasn't a lot in that world. We didn't even really have JavaScript. We had very little available to us. Now we have a ton of stuff available. And just around after we hung out many years ago, there were things like Java applets, which were little virtual machines that ran inside of our browsers. Is WebAssembly like that? Is that an analogy that's reasonable?
So it's probably a fairly safe analogy. WebAssembly is a virtual machine, but I think the thing that sort of distinguishes between different classes of virtual machines can be found in the sort of instructions that those virtual machines support. And when you look at WebAssembly, the list of instructions in there is pretty small. And there's a couple of important key things to notice about that. One is that there are no instructions for accessing the operating system. There are no instructions for I/O. There's no instructions for anything that could vaguely resemble a side effect even. And the other is that all the instructions are both CPU and OS agnostic. So, it's when you see virtual machines like the Java virtual machine, there are instructions in there that sort of reach tentacles out into the unsafe, dangerous zones of the operating system. There's really nothing that inhibits a Java virtual machine from tampering with whatever it wants to. And WebAssembly, the modules that you produce for WebAssembly, can literally do nothing without asking the host for permission.
Okay, so that implies that security is like baked in. It's not in any way an afterthought. They knew that it would be running in the browser sandbox. So
Yep.
you can't ever hurt yourself or hurt your machine with WebAssembly.
No, and you say the browser sandbox, but one of the things that I think is important for me is that the WebAssembly standard is actually host agnostic. So
Mm.
the web browser is a host for WebAssembly, but it's not the only host. And that sandbox is there regardless of whether you're using WebAssembly modules in the browser or whether you're doing something more like what I've been doing with open source for the last couple of years, which is running these modules in the cloud and on the edge.
Right. Now that's the whole point of this podcast and why we're chatting with you because, while people might be familiar with WebAssembly where you take a Unity game and compile it through a whole
Hmm.
tool chain of stuff, or something like Blazor on the Microsoft stack where you're running a whole, app with a whole UI inside of the browser, they think about WebAssembly. Uh, are a lot of people thinking about it in other hosts?
I think so. There's, I don't think the community of people who have sort of caught on to almost like WebAssembly's real hidden talent. I don't think that community is as big as it's going to be. I think once that sort of nexus of developers and companies start to realize that WebAssembly has all of these purposes well above and beyond the browser, then I think things are going to start really taking off.
I think you just found the title of this show. It's going to be WebAssembly's Hidden Talent.
There you go.
Interesting. So, running it outside of a host, if I were going to do a hello world in WebAssembly at the command line, walk me through what something like that would look like, and then we can work our way up to running it on the edge and running it anywhere.
Sure. There's a couple of different ways you can do Hello World. The usual one that you see on most of the tutorials is to use something called WASI, which is the WebAssembly system interface, and it's sort of it's part of the standard, but it's kind of an optional opt-in piece, and it essentially bridges that gap of giving the WebAssembly module access to a small subset of the operating system. So if you use WASI and the host agrees to let you use WASI, then you can access certain file type descriptors like standard out. And so the usual WebAssembly hello world is to take a language that can produce freestanding WebAssembly modules that use WASI. And, it's just whatever that language is, print line or printf is. And the compiler works its magic and translates that into a WASI call. And then when you run it in a host runtime like WasmTime or Wasmer or Wasm3, there's a whole host of engines. But when you run it in one of those engines, the engine will call your main function, and then what sort of happens under the hood is the WebAssembly module says, "Can I write this to this file descriptor?" And one of those just happens to be standard out. And then if the host agrees, then your text gets written to the console.
Okay, so let me see if I can unpack some of this and come up with some analogies, and you tell me if I'm getting this right. So, if I'm going to write a C application, just a regular old portable C app, and I need to go and
Mhm.
talk to the console, I'm going to end up eventually making a syscall in Linux or calling a Win32 API in Windows. I'm going to eventually jump out of my space, and I'm going to have to use something that the operating system makes available to me. And then in the world of Docker, we have all these syscalls that are available to us if the Docker host chooses to make them available. But you said at the beginning here that WebAssembly is an assembly language for a conceptual machine, not for a physical machine, and it can run anywhere. So then WASI, WASI, is a system interface. It's a list of syscalls, in quotes, that
Yeah.
are available to anyone who is writing a WebAssembly module.
Yes. You have to specifically target WASI as your compile target.
Ah,
But what happens there is the compiler, and there's an awful lot of what you see with some of these early demos with WebAssembly and WASI in particular that I generally lump under the category of smoke and mirrors. There's there's a lot of things that people are doing that make WebAssembly seem more responsible for what you're looking at than what's there. And so one of the things that languages will do when you target WASI is, like you said, at some point the compiler will reach this low-level syscall to go do something like write to standard out, and compilers that target WASI know enough to yank that out and replace it with a request to use the WASI function call. And so then at runtime, when your module is being invoked by either an interpreter or a JIT compiler or something else, what would have been your syscall is now a WASI import invocation.
Yeah, interesting. Okay. So there's lots of people today who are like writing Node and then running that node inside of the V8 and the node runtime. And then they put that node thing inside of a container and they put that container inside of a VM and they put that VM in the cloud. And it's Russian nesting dolls all the way down. But
Yeah.
I'm hearing that you think and others think that WebAssembly may be able to free us from a lot of that. And what do we get when we are freed from that nested system?
So, yeah, there's a number of things that WebAssembly has that we've sort of been seeking in our cloud development for years, and we haven't really been able to get. I touched on WebAssembly's security, so we know that it has it's sandboxed, its memory is secure, it can't access the host's memory. Secure units of deployment are, part of the holy grail of cloud development. The other thing is size. When we deploy Docker images, we're in many cases being charged based on the size of that Docker image and how much memory it consumes. And so when you go from a Docker image containing an app that might be, between 2 and 8 gigs to WebAssembly modules that can shrink down to less than 20K, the amount of compute you can squeeze into the same space is exponentially larger than it used to be. And part of that size also gives you things like speed and performance and the ability to send these entire modules out over the internet to do things like, you can live update an entire application by pushing a couple of these WebAssembly modules out to the edge.
Wow. I'm trying to figure out, sometimes given my age, and I'm going to say that you and I are contemporaries, I get overwhelmed with the historical context of all of this. And I think to
Mm,
myself, well, isn't this like COM objects and DCOM objects? And isn't this like RPC? And isn't this like thing that we have done before? And it feels like
yeah.
in some ways it is, but then there are, as always, refinements. So in what ways is this stuff we've done for the last 20 years? And in what ways is this entirely new?
So I think conceptually, we've tried to do things like this for a number of years. We had Flash, we had Silverlight, and we had ActiveX, and like you said, there's COM and DCOM and Corba even before that.
Yeah.
And wow, I'm dusting off all corners of my old brain today.
But like when I
Um,
hear IDL, like back in the days, if we're doing Corba
oh
or
yes,
doing whatever,
for sure.
interface description language, like an early in career person was telling me how excited they were about a particular technology. And I was like, well, isn't that just WSDL? And they were like,
Mhm.
WSDL, what's that? And it's like, well, I mean, it's just any description language for anything that we're kind of doing. I'm just trying to understand, like, does this mean that in some soon future, I'll be able to take any language, target WebAssembly and create WebAssembly modules, and that's going to free me from the complexities of the systems that we have today?
That is precisely my goal with the open source project that I've been working on, is to give you that ability. And so to sort of go back to your question about how we've tried doing this before,
Mm-hmm.
um, you know, we have tried to make all of these different things in the past, all these little virtual machines and things that you can interpret and so on. But one of the things that I think makes it so that WebAssembly has kind of gotten more of it right than we have in the past is actually stems from its limitations. So if you look at a lot of the other virtual machines and runtimes and things like that, they all tried to do, I think, too much, and they were very opinionated about what those runtimes were going to be used for. And with WebAssembly, you know, uh, you know, despite all of if you remove all of the smoke and mirrors, the virtual machine is still just a thing that allows you to pass numbers in as arguments and get numbers out as return values. There is nothing else. It doesn't even have complex data types in it. There's no structs. There's none of that stuff. And so what it forces people to do is come up with, the first thing you do when you have a WebAssembly module is try and figure out, well, how am I going to get robust data structures in and out of this? And one way is through tight coupling, and there's a bunch of tools that'll do this. There's a bunch of tools that do code generation that sort of generate your tight coupling for you. And another way is through rigid abstractions. And if if you adopt the rigid abstraction pattern, then you're sort of embracing WebAssembly's portability and versus hindering it. And so if you embrace that portability and you stay portable and decoupled in everything that you do and all the layers that you build on top, then you can actually leverage WebAssembly's limitations for some really good benefit.
This episode is brought to you by Auth0. Auth0 knows the importance of a first impression, and when it comes to your business, that first impression is almost always the login experience. And with Auth0, your user gets the convenient login experience that they want with the security and privacy that your industry demands. An identity operating system designed for developers across all industries, Auth0 makes it easy to customize your ideal login with features like social login, multi-factor authentication, single sign-on, and more. Learn more at auth0.com. That's authzero.com. It's interesting. There seems to be a burst of creativity that happens when we constrain systems, whether it be something like Twitter caused constraints by arbitrarily saying this is how long this can be. We see excitement in 8-bit systems and NES, Nintendo type stuff because it's like, no, you have fewer colors and fewer pixels than you see here. I'm hearing excitement in your voice and in your companies by saying, here is a system that is genius by its constraints that will allow us to do things we couldn't do before. It's kind of an impossible thing. Do more with less.
Yeah, absolutely. I think as a species, we tend to innovate more when we're given constraints and limitations. And what is the necessity is the mother of invention, or whatever that saying is. And I think that also applies to our industry as well. Like you said, we tend to have these bursts of evolutionary progress that come from um, periods of constraint.
Mm-hmm. So with WasmCloud, and again, folks can check this out at wasmcloud.dev. Not only do you have a system by which people can go and build and test and scale services and functions, but you've even got an actor model that lets you have business logic running anywhere. And I want to get back to that anywhere part because you mentioned the edge as well. Like WebAssembly, this doesn't just mean running, dynos in the cloud somewhere or running node pools in the cloud somewhere. You're telling me that I can deploy these WebAssembly modules anywhere.
Yep. Yeah. So a lot of what sort of fueled the initial creation of WasmCloud was, quite frankly, it was frustration and anger. Looking at decades of building enterprise applications and specifically distributed applications, every time someone would ask me to, go build a distributed application, it would almost, the burnout would set in almost immediately because I knew that I was going to have to deal with all of the non-functional requirements of building a distributed application. I was going to have to deal with the fact that I spend 90% of my time writing boilerplate and only 10% of my time writing actual business logic. So what I wanted to solve with WasmCloud was I wanted to make it so that developers could write distributed applications by simply defining business logic and pushing that business logic anywhere that business logic was appropriate. And so right now we have this sort of assumption that I can write code and then push it to the cloud and it works. And we have Heroku for and a bunch of others for that model. But I think we can take that a step, many steps further with WebAssembly, right? I want to be able to define my application as a series of composable actors, just single threaded. I don't want to have to worry about threading code because every time I write threading code, it's wrong. So I want to be able to write a distributed application without having to do all the hard stuff. So I want just to be able to push my logic into a flat topology that spans whatever I want it to. I want to be able to run my application as a single process on my laptop and then turn the scale knob and run it as 500 processes that are spanning across 3 different clouds with automatic failover.
That's kind of what the promise was, wasn't it? Like everyone said, when we all learned computers the first time, it's like, hello world.
Mm-hmm.
And then the teacher says, all right, now we're going to do this n times. And what
Yep.
you're describing is I need to do something naively and simply. And now I just want to do it n times or n times m across these systems. You're literally you're giving us the promise of computers, what they were told we were supposed to do is do
Yeah.
this simple thing at scale. And so I'm hearing you say that the application developer they build actors. That's the primary work that the developer's
Yeah.
iteration loop looks like.
Yeah. So today's iteration loop looks sort of like this, where you start off with your napkin drawing, your conceptual vision of what it is you want to build. Then you get your initial prototype, and it proves that some essential core concept of what it was you were trying to do that works. And then you have to go and figure out how to scale it. And usually, what happens between those 2 steps is a complete and total rewrite because virtually nothing from your prototype um, is written in a way that is scalable the way you want your production grade application to be. And what I want to be able to do is ship napkins to prod. I want to be able to draw my conceptual map of what my application should be, fill in the blanks with my business logic, and then just push it and not have to worry about any of the other nonsense.
So here's a question, and these questions aren't meant to be challenging, but rather are meant
Mm.
to challenge my own assumptions. Isn't that what they told us Kubernetes was for?
That is, I remember that being one of the promises of Kubernetes. There's a number of promises with Kubernetes. Um, with Kubernetes, you can, if you are uh, talented enough and have enough patience and tolerance for pain and suffering, you can build a platform on top of Kubernetes that does kind of what I'm talking about,
Mm-hmm.
but it doesn't come with things like being able to remove the boilerplate or let people just write business logic. Like I can deploy all kinds of distributed systems to Kubernetes, but there are a couple of really big tight coupling roadblocks there. One is that I need to know the shape, the final destination shape of my
Mm-hmm.
application when I push it to Kubernetes. I need to know which things are going to be in which process, and I need to know where those processes are going to run. Even if Kubernetes does the scheduling for me, I still have to tell it how to schedule, and it's still the wrong abstraction for me.
Okay.
I don't want to be shipping miniature operating systems to a platform where those operating systems don't move around the way I want them to.
I don't want to be shipping tiny operating systems around. That's deep.
So what I really want to be doing is shipping my business logic, and
Mm-hmm.
that's it.
Exactly.
So sort of, if you look at the how we've been evolving over time, Like when you and I worked at 800.com, we literally moved physical boxes from one place to another in order to move processes. Like
Yeah, in a
we were,
van.
yeah, we were meat schedulers, right, as opposed to the Kubernetes scheduler. And then we had virtual machines, so I could push a button to move a machine from one place to another.
Mhm.
And now we have Docker, and so now we're in the business of shipping many operating systems around. And what I want is what I hope WebAssembly will give us is that sort of next evolution of the deployment footprint. The thing that we build and push, every time that shrinks, uh, we get a new evolution of how we build software.
Okay, so then you're saying that WebAssembly modules and something like WasmCloud and the actor model, that's what a microservice is and should be. Like it shouldn't be, here's a microservice, now I'm handing you a container with a tiny operating system inside it and a whole contract.
Yeah, so I may be considered a heretic for holding this philosophy, but I don't feel that a microservice should have fixed process boundaries. Yeah, if I have 4 or 5 actors and I want them to run in one process on Monday, and I want them to run in 30 different processes with multiple load balancers between them on Tuesday, I should be able to do that, and I shouldn't have to redesign, recompile, and redeploy anything that I've built in order to give me that.
That is really worth exploring for a second because if I go back to again some historical things, I think about Corba, I think about COM, the promise
Mhm.
was location transparency, but it's also process boundary transparency.
Yeah,
But that was all a lie because moving something from a COM object in process to out of process was, required an act of Congress. And
yeah,
now, if I decide that the shopping cart is in a container and the identity thing is in another container, and now I want them to be configured differently and live together, that's an event. That's going to be like a
yeah.
sprint to do that.
At the very least, yeah. And when you find a vulnerability in the web server that your microservice is using, that's now your reason to stop everything you're doing, fix, recompile, and redeploy. And it has nothing to do with your business logic. It has everything to do with the fact that you've taken ownership of all the libraries that you use in your microservice.
Hmm. And then, of course, if you start thinking about software-based networking, then you've got to think about all of the network traversal, and you solve things like that with a mesh network like Lattice.
Yeah. So to your point about location transparency, yet another one of the things that is sort of has irritated me for a very long time is because, like you said, we were promised location transparency, and we don't have it. We don't even have it with Kubernetes. What we have is built-in or bolted-on service discovery, and that's not really the same thing as location transparency. With runtimes like WasmCloud, I can push an actor into my what we call a lattice, and if I want to invoke a function on that actor, I can do so without having to know where that actor is. I don't have to know how many of them are running in the system either. There's a demo that some folks did of a prototype that they built for a big European bank where they were showing an application built using these actors. And they had, some of them deployed in Google Cloud and some of them deployed in Amazon. And they just started shutting down actors and in random places, and everything still runs. And then when all the actors in one cloud were off, everything just all the traffic went to the other cloud. And then when you bring the actors back up in the other place, now the load is distributed between them. And you people who don't know or don't want to suffer through all of the amount of infrastructure that's normally required to do that, we can't, if we want to build applications that do that sort of thing today, we need to not only make a whole bunch of design time decisions and architecture level decisions to make that happen, but we also have to gain expertise in an entire stack of things that we really shouldn't have to care about. Like, I shouldn't need to be a Kubernetes administrator in order to build an application that runs on Kubernetes. That may be a heretical opinion as well, but I'm sticking to it.
I was just going to say, burn the witch.
Yeah.
Yeah, if I could do Kubernetes without YAML, I think I would be a happy person. But you're describing a world that's even better than that. So I appreciate it. Very cool. So folks can check out the open source project at WasmCloud.dev. They can learn about the docs. They can get working with that immediately. And they can check you out and sign up for early access at Cosmonic. That's the commercial side of the business, COSMONIC. This has been really great learning all about WebAssembly's hidden talent. Thank you, sir, for hanging out with me today.
Oh, thanks for having me. I appreciate it.
We've been chatting with Kevin Hoffman, CTO of Cosmonic, and this has been another episode of Hansel Minutes. And we'll see you again next week.